Practice Set 8, problem number 1, page 34. Refer to the diagram below to answer the following questions. Here we have data that is normally distributed, and in the box it tells us that these are scores from Superior College Math Entrance Test for entering freshmen for the year 2002. 200 students tested, and this was a 100-point possible test. So we'll answer the questions dealing with this graph. The first one asks us, what data is shown by this normal curve? Well, we just read that these were entrance exams. Next question asks how many students took the test, and the last piece of information told us that there were 200 students. C, the mean student test score. Now the raw data was all calculated and graphed out in this normal distribution, so the calculation is done for us. It's just a matter of us reading the values off. The middle value is always where the mean value is going to fall. So in this case, the mean for this set of test scores is going to be 70. Next, D asks for the standard deviation for this set of data. Each one of these vertical lines is indicating a standard deviation away from the previous one. So if I'm at the mean and I move one above, I've added a standard deviation to the mean. And if you notice, 70 and 79 differ by 9. Each one of these adjacent numbers has a difference of 9, an increasing standard deviation added onto each one, and we can check it going on the low side. 70 minus 9 leaves us with 61. This is one standard deviation below the mean as well. So the standard deviation for this set of data is 9. E, 95% of the students who took the test had scores between blank and blank. 95% is found by taking 2 standard deviations above and 2 standard deviations below the mean. And if we look at those boundaries for the lower and the upper, for 95%, we will answer a low of 52 and 88. So 95% of the students scored between a low score of 52 and a high score of 88. The second part of that question asks how many students would that be? Well, we need to determine the percent, which we're dealing with. 95% of the students taking the exam, there were 200 students. Converting the decimal value for the percent, we have 0.95 times 200, results in 190 of the students taking that entrance test had a score between 52 and 88. The last question asks what percent of the students who took the test had scores of less than 43. Well, we need to identify where 43 is. Here's 43. How many standard deviations is it below the mean? Well, it turns out it's 3 standard deviations below. Well, if we go 3 standard deviations above as well, 3 standard deviations above and below is equivalent to virtually all of the data, which is 99.7, but not quite all. We're interested in this portion of students that scored less than that. Well, if the whole graph represents 100%, and we know the boundaries for 99.7%, that means we're talking about 0.3%. However, That 0.3% is below this boundary value for 3 standard deviations below, and it's also the equal symmetric part for students scoring higher than 97. So to find half of that remainder, I now need to take that percent and divide it by 2. 0.3% divided by 2 results in a 0.15% of the students scored less than 43. We also could have answered that 0.15% scored greater than 97%. Very rare occurrences.